Hello everyone, I am Huang Zijie from East China University of Science and Technology. As the first author of this paper, I'm very glad to present our paper to you. It is called Predicting Community Smells Occurrence on Individual Developers by Sentiments. Here is an outline of this presentation. First, I will introduce background and our motivation. Then, I will describe our dataset as well as experiments. Finally, I will draw to a conclusion and present future work. We intend to predict community smells occurrence on individual developers, so the definition and detection of community smells is a necessary prior knowledge. Community smells are anti-patterns in development community. They are defined as unhealthy organizational structure of the software development communities. The major impact of such smells is that they cause unforeseen project costs. Before detection, two graphs incorporating collaboration and communication activities of developers will be generated. And then community smell detection is performed over the two graphs of subgroups in a software community. We predict the occurrence of the three most common community smells. The first and the second smell, called organization silo and lone wolf, refer to communication issues between collaborators. If co-committing developers are indirectly connected in communication graph, they are influenced by lone wolf. If they are not connected at all, we discover organizational silos among them. The third smell, bottleneck, is a purely communication problem. Communication among developers affected by bottleneck is seriously blocked by boundary spanners that interpose themselves into every interaction across sub-communities. Prior community smell papers aim to propose guidelines for community shepherd. For example, this table extracted from prior work outlines top-down strategies to refactor community smells. However, some communities may lack community shepherd, and resolving problems in an organization depends on the effort of every member, so we need to build bottom-up supportive measures for individual developers. We found literature reporting personalities of developers can influence their quality of work, including introducing community smell. Meanwhile, sentiment is an expression of personality. In order to support individual developers with varied personalities, we develop machine learners upon the developer sentiment dataset to predict if they are affected by community smells. For dataset construction, we have two sources of information. The first one is a sentiment dataset over Jira issue tracking system. The second one is a community smell detection tool called CodeFace for Smells. We combine these data and predict community smells occurrence over individual developers with sentiments and several developer-oriented socio-technical features. We construct our dataset based on 12 projects in the sentiment dataset because they are active and of high quality. Meanwhile, other projects do not comply with the requirement of the input data of the community smell detection tool. We extract 15 developer sentiment features measuring valence, arousal dominance, emotions, strength of sentiment, politeness, uncertainty, and activeness. After our dataset is constructed, we propose three research questions. RQ1 refers to prediction performance, RQ2 measures feature importance, and RQ3 uses statistical approaches to find the difference between smelly and non-smelly developers in terms of sentiments. We define 5 classes for prediction as dependent variables, including 3 community smells I've mentioned before, as well as whether a developer is smelly and whether a developer quitted the community. We remove 3 correlated features to avoid feature interactions. We test various classifiers and validate our models in within and cross-project prediction, and we use precision recall, F-measure, and AUC-ROC as our evaluation metrics. For feature importance, we apply information gain algorithm to measure the amount of reduction in Shannon's entropy of the model after involving in a new feature. And then we compare and differentiate features' predictive power using Scotna DSD. Finally, we compute the significance of difference in terms of a distribution of sentimental features of smelly and non-smelly developers. We also measure the effect sizes to validate our result. For performance results, our prediction model can achieve F-measure ranging from 76% to 93%. For RQ2, we found that 6 sentimental features are top predictors. Certainty is a key factor to community healthiness. Politeness and both positive and negative emotions, including sadness, love, and joy, are also powerful predictors. In RQ3, our notable conclusion includes smelly developers are less certain than the non-smelly ones. Non-smelly developers use 24% more frequently the polite expressions than smelly ones. To conclude, our model achieves acceptable mean F measures in within and cross-project prediction. We suggest developers should communicate in a straightforward and polite way to build a healthy community. Some results need investigation. For example, smelly developers express more positive and less negative emotions. For future work, a must-do is that we will validate our results with time-sensitive data and approaches. We will also consider more case studies and explore community smells in other software artifacts, such as issue tracking system. My presentation is over. For Q&A, you can propose questions or contact me by social networks.
Okay, thank you for your presentation, Juan. Since I'm not seeing any question in the chat, I can ask you some of my questions. The first one is, do you have any hypothesis of why smelly developers express less frequently polite expressions?
Okay. Impolite comments. It will it will decrease the willingness of the participants to communicate. So less communication is one of the main cause that triggers the community smell. So I think the impolite comments will be the preventers of refactoring and cause community smell. Yes.
Okay, great. Anyone has more questions for Juan? Please remember that you can type them in the chat. Okay, probably another question I have is, how do your results can improve the communication to mitigate community smells?
Okay, wait a second. I saw, okay, there's a comment showing up. Yes, impolite developers are not good developers. I can't say they're worse, but they are not good. Okay, how can my model improve the communication? I mean, in my assumption, we should build a predictor for every team. We should express the prediction result for every member of the team for example, on the corner of the GitHub page, something like that, and let them know that if they would be suffered from community smells because of the lack of the communication. In the future, we will foster the explanation of the model, so the developers will be able to know why they tend to be affected by community smell, so that they can adjust their behavior and to build a healthier community. Yes.
Okay. A quick question from Anita: can the system identify impolite, mean versus just abrupt matter of fact, so not really polite?